Welcome back to Computer Hardware, Bits and Bytes. This is an introduction to Unit 3, the CPU. So you're on your computer, and all of a sudden, you need to figure out 93 plus 42, and you don't feel like doing it in your head. So you make the computer do it. But what does the computer do? What happens in its head? For the answer to this question, we journey into the brains of any modern computer, the CPU. CPU stands for Central Processing Unit. You can think of it like a computer's brain, and it works kind of like ours. We'll take a look together at the different structures inside a CPU and connect them to structures we have inside our brains. First off, it has working memory, except called registers. And while us humans can only store 5 to 9 things in our limited working memory, a computer usually has up to 32 things at once. And by things, I mean a collection of zeros and ones, representing a number. So most all the data that a computer processes first must pass through these 32 registers. Second, there is the logical mind of the computer, which is called the Arithmetic Logical Unit, or ALU for short. This is where the data in the registers are actually manipulated. The ALU usually takes two numbers from the registers and combines them in some way. Some of these combinations are mathematical, like add and subtract, and others are logical, like and or. And then, it puts the result back into a register. So for any operations that are mathematical or logical, which is actually most of what a computer does, the data will go through the ALU. What happens when us humans run out of working memory? Well, we have long-term memory. In a computer, this is called random access memory, most commonly known as RAM. And when we run out of registers, we can move our information into the RAM. Also, RAM is where most of the memory is located for the current tasks at hand, so we can move it back into the registers for our working memory. RAM, registers, and the ALU. Pretty much everything a computer processes flows through these three structures. So these parts of the computer work together to form the basis of the CPU. Let's test your knowledge. Question 1. Can you name the three CPU parts we talked about so far? If you said RAM, registers, and ALU, you are correct. Question 2. Related to our example. Where would we add two numbers? The ALU, or Arithmetic Logic Unit, is correct. Nice work. Alright, this is cool, but isn't there some magic missing here? How does the computer know what to do? So computers do all these crazy things and seem really smart, while in reality they are not so smart because they can only do what they're instructed to. So part of the RAM is filled with instructions, which we call the program memory part of it. So all that code that computer programmers write is split up into bite-sized chunks and put here into program memory. It's just like other memory, except that the computer knows it has instructions instead of numbers or letters. So what can we tell the computer to do? All the instructions that a computer has are defined in the CPU's instruction set. There are three main types of instructions. Some use the ALU with numbers from the registers, like add and subtract. Others move data from registers to RAM and back. For example, the load instruction can move data from the RAM to the registers, and store does the opposite. And the last type of instructions change the way that the program flows. So if you add a number 50 times, you can just have one line telling it to do that 50 times instead of 50 add instructions. We'll focus mostly on the first two categories. Now let's move to question 3. How does a computer know what to do? If you said instructions, or we tell it to, that's right. Question 4, relating to our example. Where do numbers need to be so that we can add them in the ALU? That's right, the registers, because the add instruction only works from the registers to the ALU. Now let's go back to look at how all these parts work together to solve our little math problem, 93 plus 42. Well, first, these numbers we punched in are somewhere in RAM, except now they look like zeros and ones in their binary version. Still the same number though, and they are in their own spot in memory, labeled FF00 and FF01. These spots are called their address. Yep, almost like they live there. And then we have the RAM, with the two numbers in it at their addresses, and also the registers. So ultimately, to add the numbers, we need them in the registers, right? How would we do that? Let's see if you know. Question 5. How do we tell the computer to move the numbers from RAM to the registers? The load instruction is how we do it. So we tell the computer to move the numbers from memory to the registers by two load instructions. So the 93 in FF00 goes to R0, and the 42 in FF01 goes to R1. Question 6. How would we tell the computer to add the numbers? If you said an add instruction, that's right. Remember, the computer can only do what we tell it to. So the next instruction we execute is adding R0 and R1 in our handy ALU. So it moves R0 and R1, adds the numbers, and then outputs it back into the registers. So now the computer has calculated 93 plus 42 and spits out 135. Wow, a lot happened just for one simple thing. And now, you know some of the brains behind the CPU. Hope you stored something from your registers to your RAM today, if you know what I'm saying.